The discovery and understanding of magnetism have a long and fascinating history that spans over thousands of years. The journey of discovering and unraveling the mysteries of magnetism began with ancient civilizations and continued through the work of countless scientists and scholars. Today, we will explore the key milestones in the discovery of magnetism, from its ancient origins to the development of the modern understanding of this fundamental force. The origins of the discovery of magnetism can be traced back to ancient civilizations, particularly in Greece and China. Around 600 BC, the Greeks observed that certain stones, particularly the naturally occurring mineral magnetite, had a mysterious property of attracting iron objects. These stones, which they called magnet, were the first magnets ever discovered. The Chinese also had early knowledge of magnetism. By the 4th century BC, they had discovered the magnetic properties of magnetite and developed primitive compasses using magnetic needles to aid in navigation. The knowledge of magnetism continued to evolve over the centuries. The Greeks and Romans observed that a piece of iron, when rubbed against a magnet, could itself become a magnet temporarily. This process was the first glimpse of what we now know as magnetic induction. In the 12th century, Chinese scientist Shen Ku documented the directional property of the magnetic needle in his book, Dream Pool Essays. He described the use of compasses for navigation and how they pointed to the north. During the medieval era, the understanding of magnetism remained limited. However, scholars like Petrus Peregrinus, a French scientist, made significant contributions. In the 13th century, Peregrinus wrote the first detailed treatise on magnetism, Epistola de Magnet, where he explained the properties of magnets and the concept of magnetic poles. The age of exploration in the 15th and 16th centuries significantly expanded the knowledge of magnetism. Navigators and explorers relied on magnetic compasses to traverse the seas and oceans. However, they also noticed that the magnetic needle didn't always point directly north, leading to the concept of magnetic declination. In the 16th century, the English scientist William Gilbert conducted extensive experiments and research on magnetism. In his book, Demagnetism, published in 1600, he laid the foundations for modern theories of magnetism. Gilbert proposed that the Earth itself was a giant magnet with a magnetic core, explaining the behavior of compass needles and the concept of magnetic poles. The 18th and 19th centuries marked a period of significant advancements in the understanding of magnetism. The French physicist Charles Augustin de Coulomb formulated Coulomb's law, which described the force between two magnetic poles. Later, Hans Christian Oersted discovered the connection between electricity and magnetism when he observed that a current-carrying wire could deflect a nearby magnetic needle. In the early 19th century, André-Marie Ampère developed the theory of electromagnetism, which laid the groundwork for understanding the relationship between electric currents and magnetic fields. His work paved the way for Michael Faraday's groundbreaking experiments. Michael Faraday, an English scientist, is one of the most influential figures in the study of electromagnetism. In the early 1820s, he demonstrated that a changing magnetic field could induce an electric current in a nearby conductor. This discovery of electromagnetic induction was revolutionary and laid the foundation for the development of generators and motors, enabling the widespread use of electricity. James Clerk Maxwell, a Scottish physicist in the mid-19th century, mathematically formalized Faraday's ideas into the famous Maxwell's equations, unifying electricity and magnetism as electromagnetic fields. Maxwell's work became the cornerstone of modern electromagnetism. The 20th century brought about a deeper understanding of magnetism, thanks to the development of quantum mechanics and the work of eminent physicists like Werner Heisenberg and Paul Dirac. Quantum mechanics provided a more comprehensive explanation of the behavior of electrons and magnetic materials. The discovery of ferromagnetism, antiferromagnetism, helped explain how materials can be permanently magnetism. The understanding of superconductivity and magnetic domains further enriched the knowledge of magnetism. Additionally, technological advancements allowed scientists to study magnetism at the atomic and subatomic levels. Techniques like nuclear magnetic resonance, NMR, and magnetic resonance imaging, MRI, became invaluable tools in medicine and scientific research. In conclusion, the discovery of magnetism has been a journey of continuous exploration, starting from ancient civilizations' observations to the modern understanding of electromagnetism and quantum mechanics. From the use of compasses for navigation to the development of cutting-edge technologies, magnetism has played a crucial role in shaping human history and scientific progress. The study of magnetism continues to be an active field of research with applications in various disciplines, from fundamental physics to medicine and engineering. I hope that you like our story for today. Please hit like and share this video for additional knowledge for our younger generation. And don't forget to subscribe and follow our page. Thank you so much for watching, and God bless us all.